For this one, you have to go inside the parentheses first. 3 times 2 is 6. 8 minus 6 is 2. 2 squared is 4. 4 times 4 is 16. Of course, 3 squared is 9. Add those together and you get 25. On this problem, you have to do 6 times 4 to get 24. Divide that by 2 to get 12. 9 times 3 is 27. 27 and 12 is 39, minus 1 is 38. On this problem, you have to go to the parentheses first. You have to do 3 minus 1 is 2, and then square it to get 4. Then multiply by the 2 to get 8. Then you'll have 6 plus 8. This is 12 on the back end, 4 times 3. So 6 plus 8 is 14, plus 12 is 26. Pick a number from 1 to 5. The winning number today is 4. The homework check for today is not worth 50 points. It will be worth 100 because you had double the amount of problems. The after-test assignment had 20 on it. We have 17 out of 21 with homework today. That translates into 81%. I'll show you the answers and then you can ask questions about them after we go through the answers. Number 1 is 33. 2 is 27.5. 3 is 122. 4 is 13. 5 is 45. 6 is 13. 7 is 84. 8 is 14. 9 is 29. 10 is 108. 11 is 9. 12 is 13. 13 is 19.5. 14 is 5. 15 is negative 17. 16 is negative 12. 17 is negative 12. 18 is 65. 19 is 287. 20 is 56. Test review is up next. Number 1 is 5 hours 31 minutes. 2 is 71 feet. 3 is 2 hours 18 minutes. 4 is 6 feet 2 inches. 5 is 2 feet 5 inches. 6 is 102 feet 2 inches. 7 is 2 hours 57 minutes. 8 is 5 feet 6 inches. 9 is 3 feet 5 inches. 10 is 4 hours 46 minutes. Extra credit A is 27. B is 34. C is 22. D is 104. E is 24. Today's objective: Quantities, reason quantitatively and use units to solve problems. It's the same objective as last week, except we have to finish this one part at the very end. Choose and interpret the scale and the origin in graphs and data displays. Today's knowledge targets. Choose appropriate units to represent a problem when using formulas or graphing. Today you have a bunch of multiple choice problems. Your homework tonight is multiple choice. These problems are all word problems and you have to think. These are not intended to be really easy. You just have to think, and you don't even have to show any work. None of these require any work, but you have to think. Example 1. Before we do example 1, we have to review some basic things. For example, this is a bar graph, obviously, but each of these blocks here, up the side and this side, are units. Just one unit. And down here you have the x-axis, this is the y-axis. Each one of these blocks, if they're not marked, is just one unit. But there's nothing that says you have to make it 1, 2, 3, 4, 5. If you're making the graph, you can do them by 10, 20, 30, and so on. It's whatever you want to make it if you're making the graph. So George is making a bar graph. So he'll have a graph that looks like this. And he's going to show the distances from his hometown to 5 other cities in the area. The distances range from as low as 5 miles to as high as 25 miles. What should each unit on the bar graph represent? Now, each unit is the hash marks that go up the side there on the y-axis. Should we make each one worth 20 and do it by 20, 40, 60, 80? Should we do it by 1 kilometer? Or should we go by 5 miles, like 5, 10, 15, 20? Or should we make each hash mark worth 10 feet, which would take a lot of time to get to a mile? Which one do you think it is? Yes?
C, 5 miles.
C, 5 miles is right. That would make the most sense, because otherwise you're cramming everything so far tall, you'd have to go to the hundreds of feet of paper to make that graph if it were 10 feet. Kilometers is the wrong unit, and 20 miles, if you go 10, or not 10, but 20, 40, 60, everything is going to be underneath 40 because the highest one is 25. So it doesn't make any sense. Therefore, the right answer should be C. George is going to make another graph. This time, the distances range from 30 to 240 miles. So he'll make a graph. He has his units on the y-axis, and he could put more on there. I'm just putting that many. Should each one represent 1,000 feet, 1 mile, 5 kilometers, or 30 miles? What do you think? Which one?
D.
D as in dog? Yeah, 30 miles, because you're going to go 30, 60, 90, and you'll get to 240 after 8 hash marks. 5 kilometers is the wrong unit. 1 mile, you'd have to make 240 marks. And 1,000 feet, you'd have 5 marks for every mile. So 5 times 240, 1,200. 1,200 marks you'd have to make. So D is the right answer. Example 2. Here's a quick review of slope. I know you've had slope in junior high, but this is a quick review in case you forgot anything. Slope is rise over run. The rise is the y-axis part, and the run is the x-axis part. So here's a quick line that I drew, and the run is from left to right. The rise is up and down, how tall it is. If slope is 10, for example, then it is really 10 over 1. All slope is a fraction, even if you're just given one number. If you're just given an integer like 10, you put it over 1. So that means you go up 10 and to the right 1, or to the right 1 and up 10. So if slope is 10, it's 10 over 1. And remember that the top part is the y-axis. It's the up and down. and the bottom part is the x-axis. It's left to right. If you remember those things, you can't go wrong. If you get them confused, you're going to miss everything. You have to know that the run is the bottom, the rise is the top. That's the main idea behind that. So here's the slope of 5. It has a run of 1, and it has a height of 5. Slope of 1, height of 5. So here's the problem. Given a line with a slope of 150, what would be the ideal intervals in the coordinate plane for both the x and y axes? In other words, how many units per gradation, and that big word means elevation or lowering down, should there be for both x and y axes to see the line as best as possible? So remember, when you do slope, here's your y-axis and x-axis, and if we have a 150 over 1, you're measuring the 150 on the y and the 1 on the x. You're just making one movement to the right on the x, but 150 up on the y-axis. So which one of these scenarios would be best to choose for this? Yeah.
C.
He says C. All right, so if we have C, here's our hash marks. And since we only have a movement of 1 for x, we really only need to keep these 1, 2, 3, 4, and 5. So if you can figure that out, that much of it, you can go to your choices and look at all the ones that have 1 for x. We have A and C, which means these two you can cancel out. Now we have to look at the y part. Should we do 50, 100, and 150 to illustrate a line with a slope of 150? It's pretty big slope. It's almost going like this. It's almost straight up and down, and it's kind of hard to see it when you're just in this one little box. So there is such a thing as having the graph that's too big. There's also such a thing as having one that's too small. Which do you think we should use? 10, 20, 30, 40, 50, or 50, 100, and 150? Yes. She's choosing A, and she is right. Because A, 10, 20, 30, 40, 50, it's 15 marks, which is reasonable. And it will show you the movement of that line from left to right as it goes up. But if you just choose to keep it down in here, notice, like especially on a graphing calculator, you probably wouldn't even be able to see that much of it if it were just 3 unit markings. So A is the right choice. This one has a slope of 300. What is the x movement of this slope? We're rising 300. How far to the right are we going? 1. So what answers can we eliminate in A, B, C, and D? Yeah. C and D, yeah, let's eliminate those. So now our choices for Y are to go 25, 50, 75, 100, and so on, or to go 100, 200, 300. Which would make more sense so that we could see the graph? Blizzard. B is right. And for 25 into 300, that would mean you would have 12 markings. And it would best illustrate it. If you only went 100, 200, and 300, you're not going to be able to see very much with that. So it should be B. George is making a bar graph to show the distances from his hometown to 5 other cities. They range from 3 miles to 10 miles. Should he make the unit markings on his y-axis 1,000 yards, 3 miles, 4,000 feet, or 1 mile? How many people think that it's A? How many think it's B? How about C? And D? Ah, you're right. Everybody chose D. The answer is D. Practice number 2. Given a line with a slope of 5, what would be the ideal intervals in the coordinate plane for the x and y axes? How many think it would be A? How about B? Bunch of people choosing B. Let's see, we have close to 13. How about C? How about D? All right, the right answer for this would be B. So you are right. How many yards are in a mile? You can raise your hand if you think you know it, and we'll see if you have it. All right, what do you got? He says C, and he is right. 1,760 yards in a mile. How many feet are in a mile? Who knows this one? Yes. B is right. 5,280. How many inches in a yard? Deerfield. Not B. That's 12 inches in a foot. Oh, D? He said D is in dog, so he is right. 36. 36 inches in a yard. All right, here's the new objective for this week, and we'll include the old one on the next test. Define appropriate quantities for the purpose of descriptive modeling. Now here are some more multiple choice problems. Kenny has a jar full of coins he's been saving, just like he's been doing every year. Which would provide Kenny with the most accurate idea of the amount of money he has in the jar? Counting the number of coins, weighing the jar, measuring the volume of the jar, setting up a proportion between the height of the jar and the amount of last year's height yielded. How many think it's A? 1, 2, 3, 4, 5, 6. All right. How many think it's B? How many think it's C? And how many think it's D? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. The right answer is D. Read the question again. Kenny has a jar full of coins he's been saving, just like he's been doing every year. Notice that shows up in this answer. Which would provide Kenny with the most accurate idea? Idea is another way of saying another word that starts with G. Guess. Yes. Of course you could count the number of coins in there and get the exact one, but what would be the purpose of the word problem though? So this would be a really easy problem, and these are not easy. So you would set up a proportion with the height of the jar. Now the height of the jar doesn't mean necessarily the actual height of the jar as it does the height at which the coins reach in the jar, if you're using the same jar every year. So the answer would be D. Set up a proportion so you could solve for an estimate of what it would be for this coming year. Example 4. In December, Phineas is trying to predict the cost of gasoline in his hometown for the summer. Which will give him the most accurate prediction? A. Find the cost at every station in a 3-block radius. B. Finding the cost on Memorial Day for the past 15 years. C. Finding the percent increase between regular and high octane. D. Asking the gas station attendant. How many think it is A? Nobody. How about B? We have 1. How about C? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How about D? No D's? All right. The right answer for this is B. Finding the cost on Memorial Day for the past 15 years. What month is Memorial Day in? May. And what season comes after May? Summer. All right, so if you look at the cost for Memorial Day, which is right before summer, then for the past 15 years, you may be able to have an accurate guess of what it would be. The cost at every station in a 3-block radius has nothing to do with the current time. It's also just in a 3-block radius. It's not going to matter. The type of gasoline was not mentioned. And asking the gas station attendant would only give you one gas station at that current time. So the answer is B.